The next tool path we'd like to talk about is a 3D offset tool path. This can also be called constant step over. This means that the step over on the part is going to be exactly the same whether you're going across a flat surface or down a steep surface. To get to 3D offset, we move up to NC, down to 3-axis, and down to 3D offset. SURFCAM asks us to select the cut surfaces, so we click on Visible. I'm going to change my tool information to a 3/8 ball nose end mill as we used before. And I'm going to change the tool number, length offset, and diameter offset to 1. Next we'll move to cut control. In cut control, the critical information here is the step over. Since we have one step over for the entire part, we don't have to have a designation for steep or shallow. In this part, I'm going to put in 0.02 or 20 thousandths, and then we'll move down to the next field. Even though we have a constant step over of 20 thousandths, we can leave different amounts of stock in XY or in Z. Our angle range is 0 to 90, as it was in steep shallow, and we can adjust this for whatever amount we desire. I'm going to click OK down at the bottom and see what we get. Here's the final result of our 3D offset tool path. There are several things to look at as we zoom in more closely. The first thing you'll see is we have a single entry pass, and then the tool begins radiating outwards at a 20,000 step over. As we transition over the edge of the part, we still get that same 20,000 step over. The 3D offset tool path is essentially a single tool path across the entire part. Another thing to notice is this line here. As we transition from one Z level to another, we move across the part at a 30-degree angle, and then when we get across the base, we maintain that same 30-degree angle. This is adjustable in the Leads and Links tab. We're going to go there now and make an adjustment to that. I'm going to go into the Operations Manager and regenerate the tool path with original geometry. I'm going to go to the Leads and Links tab, and right down here on the Feed Between strategy, we have a tangential ramp. The ramp angle is 30 degrees. That's what you see on the part. I'm going to change the tangential ramp from ramp to direct. I'm also going to change my retract strategy from full retract to shortest route. Click OK, OK at the bottom, and we'll regenerate. Here's the previous 3D offset tool path modified with the tangential ramping move changed to direct and the retract strategy changed to shortest route. As you can see, we don't have the same up and down retract moves that we had before. All retract moves are taking the shortest route to get to the next position. If we look at this in a top view and zoom in, you can see that our transition between cutting passes is on a direct line and not at the 30-degree line we had before. So the tool will move around in the first cut, step out, move around again, and we'll have a direct strategy all the way to the edge of the part. Remember, these options are there for a reason, and you can adjust the options to suit the part you're trying to make. What we're going to look at next is an entry move into the part. If I zoom up in this location, we can see a basic entry move into the part. We wrap it down to slightly above the part and then feed into the part. This is controlled by our ramping strategy. If I go to the Operations Manager and regenerate our tool path, I can go to the Leads and Links tab and change my ramping style from none to either profile ramping or helical ramp. I'm going to change it to helical ramp, and we get a basic set of parameters to program. I'm going to accept the default values and then click OK. Here you see the result of our helical ramping strategy. We wrap it down to an initial start point and then make a helical motion until we're in contact with the part surface. From that point on, we're into our 3D offset cut.